Hello guys, so in today's tutorial we are going to discuss much more about Snowflake and some of the Snowflake features, and we'll build one small application including all these features. So this video will be one high level introduction to these features and implementation of those, and in the next video we'll go detailed discussion, we'll do detailed discussion regarding all these features, and we'll build more complex solutions in the next video. Okay, so today we are going to discuss time travel in Snowflake, streams, tasks, and stored procedures, and I'm going to use Python for easily writing, because most of the data scientists they are already well familiar with Python, right? So what is time travel in Snowflake, right? So time travel allows you to query beyond time your historical data, your records that's available, whether it's in schema level or database level or table level. You can query the data basically up to 90 days depending upon what edition you are using of Snowflake, and you can query, you can clone, you can restore historical data for some specific period. That's what time travel. So it gives you query data beyond time. Okay, so the data might be present, let's say 10 days ago the data might be present in the table, but with the current version of table there might be some modification happens and that particular record is not there, but it is required, or you required that data, or that data is required for some business logic. So you can use time travel to restore that data, and you can utilize that data. So what are the key features of time travel? It's basically you can query historical data using at or before clauses that we will see just right away. Then you can restore tables, schemas, and database, definitely, right? If you can query beyond time, then you can definitely restore your table, schemas, and databases. Then you can clone those to a specific timestamp. Okay, now for having if you wanted to do time travel in Snowflake, there is some access limitation for all the features, right? So account admin role can only modify the time travel settings, and the user who is going to use the time travel, they need select privileges to the query to query the time travel. So upon your database you need select privilege, and only account admin can modify the settings of the time travel. Okay, now let's quickly see example of time travel. So let's say I'm using this database named YouTube, and if you are going to create this example schema, so this example schema is already there, and let's say then you are creating one table like this trade order, where we are passing this attributes to the table, and then you insert some of the data here. Okay, now your table is ready, right? So if you query the data, you should see some records, right? So I'm just querying this part, and for the time being for this tutorial, just don't if you are just new to Snowflake, ignore all of this, right? Roles, warehouses, worksheet, databases, we'll go through once we'll okay read about all of this. Okay, just okay, so it says that this example is not there, right? So let's just create quickly, no issues, we can create along the way, it will not take much time. So the schema is created. Within the schema you can see the table got created. Now I'm going to insert some of the data into the table. Okay, see 10 records got inserted. Now if I query this table, I should see 10 records, right? So here you can see all the 10 records are coming. So this is pretty normal, right? Now let's say accidentally I write this query, so I am just doing a drop, right? So let's say accidentally I am dropping the table. Now if I again query the table, it should ideally give me no records, right? See, it is saying that this object does not exist or not authorized, right? Now with the help of time travel, I can use a command like this undrop, okay, and uh, it should restore the table. So that is not this facility is not available in the databases, the legacy systems and all, right? So with Snowflake, you can see now you can come again. If you do the query, you will see the records coming up, okay. And these are some syntaxes for the same, right? So if you use a offset and if you pass the time frame and then you hit the query, you will see the older records of 1 minute older, right? So 60 times 1 is 60 seconds here. So if I do a 10 minute, it should throw me an error because the age of this table is less than 10 minutes we just created, right? So that's why you will see this error here. So yeah, if it is older than 1 minute, right, it is definitely older than 1 minute. So I can easily get that track in time and fetch, okay, 1 minute ago what is the condition of the table looks like, okay. Now it is 10 records, right? So how you will understand now? Let's say again I am going to insert, let's say control C, and you are going to insert another record. Let's say this time, let's change it a little bit, okay. One row got inserted, right? Now if you do a select start, it should give you 11 records, right? Here you can see 11 rows got returned, okay. But if you query this, syntax with the offset, so 1 minute prior, you will see it should return you 10 records. So the newly inserted records was not present 1 minute before, right? So this is the use case of time travel. So you can go beyond time and you can query particularly that instance of time in with your database, with your schema, with your tables, okay. So we'll talk in much more details regarding this time travel in the next video, where we'll be discussing all the more complex and complicated features if it is available in Snowflake. Now the second topic is streams that will be required in this project. So a stream is nothing but it used to capture the CDC or change data. That means it will capture events like your insertion, delete or update from a table, and these are the key features mostly for any stream. It tracks the changes in real time. It used for incremental ELT, ETL and auditing, and works with Snowflake tasks, okay. At the same time, a user who needs to have access to stream requires monitor, select and insert privileges on the stream, okay. And your Snowflake tasks are nothing but automated SQL scripts or procedures, okay. So a SQL Snowflake task is basically a cron job that you can schedule or you can run on demand, and it is nothing but a sequence of SQL statements or procedures, and stored procedures are nothing but your SQL statements, okay. So it supports recurring. These are the three key more, okay. All right, now let's see some of the examples for task and streams, okay. So here you can see you can also clone basically from your time travel. So this query will give you a clone in time, okay. And you can also alter the time travel restoration date. So the syntax for it is data retention time in days, okay. Now in stream, so it's similar. Create stream name, and you have to provide on which table you want to create the stream. So this syntax will create one stream. Okay, let's just create a stream. So what it will does, it will create one stream object on this table. Okay, now ideally this stream does not have any data, right, because there is no change data happened. So if you query the stream, you will see there is empty data. You can see here, and you can see three metadata tables, three metadata columns that appeared. Metadata @action, what are these action type, whether it is an update, and the row ID. So these things will be discussing in detail in the next video. Okay, now if I now just simply insert another record in the trade orders table, then if you again query the stream, you will see this record is consumed by the stream. Okay, so you can see all the details, and in metadata details you can see it's an insert type of action. It is not an update, and the row ID, corresponding row ID. Okay, so this is all about stream for now. And again in task, what is task that we have just discussed? Task is nothing but automates your SQL executions basically, or stored procedures used in data pipelines, right? So it's a automation of your SQL execution. So how you create a task? Similar syntax, create or replace task. So as it's an automation process, right, you have to provide the process engine. So process engine in Snowflake is your warehouse details, so you are providing the warehouse. So here I'm using this example warehouse, so I'm providing that. And as it's a schedule job, right, you can also schedule tasks, so I'm providing a schedule of every 1 minute, right? So within every 1 minute interval it runs. And what I am doing inside, I am running one SQL script basically, that says that insert into some table and select the data from the stream. So I'm just consuming the stream. Okay, so this table is not present, so it will throw me error. So first I have to create the table. So I'm just run this command, it will create the table. Okay, so then if I run this task, it will create the task. Okay, so once the task is created, you can immediately run by this command by doing alter the task name, and you mention that let's resume the task. Okay, so it will create the task. Okay, and now if you query this metadata information, that what are the tasks are present in the schema, basically it will show you the details of the task present in your schema. So likewise here you can see this process my stream, this is our task name, right? You can see the database details, schema details, owner details, warehouse details, scheduling details, what is the definition, and what last run, when it last run, who is the owner. Okay, and all the details you can see. Now if you do a select star from information schema task history function, you can get all the details of all the available tasks for that database, provided you have access to information schema. So here you can see these are all the tasks that are currently running in this database. Okay, so yeah, that's it for task. So in this short span you have learned about time traveling, streams, and task. In the next example, we'll just deeply high level touch what's a stored procedure. So stored procedure is nothing but your SQL commands running sequentially, or execution of SQL commands in an administrative way. Okay, that means there will be multiple couple of SQL commands that you will run from your procedure. Okay, so in Snowpark you can write Python codes that will be much more familiar to your pandas or your Spark kind of syntax, and that internally it will get converted to Snowflake SQL, and it will get executed in the engine, and it will return you the expected output, whatever you have written. So likewise here, if you see this line, so what we are doing, this session object will store your connection details. So once it's just like, you know, a database connection from your any Python script. So once your session object is established, you are using this SQL command, and you are passing select star from trade order streams. That means whatever stream data is there, you wanted to do a select on top of that. Then you wanted this two pandas method will convert that SQL result to a pandas data frame, and once that data frame is available, we are just storing the data frame in this df object. Then you can do regular data frame operations. So df price equals to, let's say, df price times 1.05, so 5% increasement of the price, and this is some random transformation that we do on top of this data frame. And once that is done, we are just printing the data frame, and we are writing it back to trade orders clone table. And if the table is not available in the schema, then we have mentioned this auto create table equals to true, it will recreate the table. And once that is done, our return type here in this settings, you can see our return type is table, so we are just returning Snowpark session table. Okay, and this is a simple procedure. Okay, now you can run this procedure, you can deploy from a single click. So if you deploy, it will create the Python wrapper on top of this lines basically, and it will create a stored procedure written in Python language. So these are the four basic things that I wanted to share just before diving into the project. So I'll quickly finish that project as well. So you will have a high level understanding of task, stream, stored procedure, and time travel in Snowflake. And in the next video, we will do all these same things with detailed. So we'll go through detailed of task, stream, complex procedures, as well as time travel and failsafe. Okay, so this is the basic level. So what our project is, so this is the flow diagram of the project for this video. Okay, so we are trying to build one trade order management system where every time user, you know, do some buy sell in their application, all the details will get inserted as new trade orders. Once the trade orders comes, that means insertion happens, right? The stream detects new orders, then the task processes the orders. Then in the application side, what will happen in the OLAP side, it fetches the historical trade data, it displays the trade data, it displays some graphics. Okay, and it tracks the order execution delays. So once all the available information is there with us, then internally it tracks the order execution delays. And once you have that order execution delays, what it does, it compares the execution time, it detects some delayed execution, and in price impact analysis, it does some trade versus market price, the actual price where the user executes the price versus what the market price at that moment. If there is any slippage happened, to it identifies the slippage as well. And in advanced let's say trading analysis, you can also build a dashboard for volatility analysis, order flow imbalance, moving average trend. Then for alert kind of situation, you can detect the large trades, you can identify volume spikes, and in the reconcile phase, you can track all the cancel orders, you can analyze the failed versus successful orders. So this is a simple overflow with the details that we have already explained, right? Using task, stream, stored procedures, and time travel, we are going to build this application in Snowflake using Snowflake native features, and we'll be building one application like this. So this will be our final output here. So where you have a trading dashboard management system kind of a thing. Okay, so let's quickly go with the flow, and let's understand how the project we have built. So first there will be insertion of new trade orders, right? So if I go to the SQL script, by the way, I'll share all the scripts available required to build the project. Okay, so you can see this is the table on which all the data are getting inserted based on this flow. So new trading, when the user executes some buy or sell from their mobile, let's say they have Zerodha or Grow or whatever trading application, right? So all those buy and sell orders got inserted in this table, let's say. Okay, on top of this table, what we are creating one stream to track all the change data, right? Every time there is some insertion, we are keeping track, okay, using this stream. Okay, and then what we are doing, we are writing one task, or we are creating one task on top of this stream to consume this data that got inserted. Okay, so yeah, here is the code for your task. So what we are doing in this task, see, we are updating the status as soon as the if you see, the default status is pending. So as soon as the order got inserted into the table, we are just updating the status to execute it. Okay, and for which orders we are updating the status, those orders that are available in stream. Okay, so within this stream, if you have any data, just update the status of the data to execute it. Now next, what we are doing, we are fetching the market price. So these are some random values that I have used for configuration of the market price. Okay, just give me a second now. Sorry for the inconveniences. I think the Streamlit application is consuming a good amount of RAM memory. Okay, so we are setting the market price, we are setting the execution time, we are setting the status, and we are calculating the slippage. Okay, for every new inserted record. Once that is done, we are calculating the flags. We are just flagging the trades, whether it's a high slippage flag or not, if you are having a slippage value of greater than 5. So this is some set of instructions that we are executing under this task, and we are scheduling this task for every 1 minute. Okay, so let's say within 1 minute you are getting 150 rows or 200 rows, or upon that 200 rows or 150 rows, this many updates will perform. And once the task is let's say completed, right? So let's just insert some of the records again. So let's just copy until this. So now if I do a select star from this records, right, that's already available data. If I do, you see I have 172 records, right? So let's do a select, just doing one count for understanding from trade orders table. So you can see I have 172 records currently in this table. So let's just quickly insert 4 new records here. Okay, so if I now insert this 4 records, so 4 records got inserted, right? And previously I have 172 records, old records. So now if I query this stream, right, this is the stream that we have created on top of this table. So now if I do a select, okay, start from this stream, I should see these 4 records in this stream, right? Because these 4 records are part of now this CDC on top of this table, and you can see the status here, all status are pending. There is no slippage value, market value, execution value, and all, right? And all are termed as trade flag as normal. So this is the data that we are getting from the system. That is your step 1, inserting the new record, right? Now your stream detects new records, so that is this line, right? So this line, you can see this, all these 4 newly inserted records. Our stream detected these records. Now what will happen? Now the task will process the orders, right? So whatever new orders are coming, the task will process. Now if I execute the task immediately, okay, I execute this line, so this task will get executed immediately. How you can see? You can come to the task history. Let me open in another tab. Okay, now in task history I can see, right? So you can see just now this task got executed. Okay, and I can click here and I can see more details about the task. Okay, I can see the query profile and all. So query profile, it will be bunch of updates, statements, right? So you can see, okay, the query profile. In query details you can see, okay, these are the queries that got executed. You can also get all the details like any other Snowflake queries, right? So that is not a part of this project, right? So once I executed, now if I do a select star, right, select count star, I should see a 176 records will get inserted, right? So see, all the 4 records got inserted, and now if I see the values at the very bottom, I will see all the details of this, right? So I can see the market price, I can see the status got changed to executed from pending, I can see the execution time and all. Now if I again hit this command, that means if I again query the stream, I will see there is no record because all records got consumed via task, right? So these 3 lines, these 3 blocks we have already seen. Now the 4th one, what it will happen once the task is done, we'll write some stored procedure for doing further processing or for creation of this management system. Okay, and once that is done, we'll write one Streamlit application for further analysis and creation of those graphs, right? So this will be the next set of understanding of blocks. So all this will be in Streamlit. Okay, so once this is done, our task, our stream, and our time travel is already done. So we'll now go to the procedure where we'll have the time travel details, right? So this SQL script is done. Now here we have written 2 procedures for data processing. So this procedure named as get historical trade, that will get me all the historical trades when the user will provide me the time. So let's say the user wants all the last 10 minutes historical trade, so he will or she will input the offset time minutes as some integer. So let's say 10 minutes, that means he or she will input 10 as a value, and this procedure is nothing but a Python procedure. It will run a SQL that selects star from this table at a offset of this value. So this is a very simple procedure that will return me all the records that the user have for that particular time frame, right? So if I use it as 10 and if I run, let's say not 10, let's say if I use it as 1 and if I run, okay, I will see all the records comes to 176. That's the latest one. But what will happen if I use a 10 minute, right? So 10 minute before I did not have 176 rows, right? I had only 172 rows because these 4 rows I just inserted, right? 1 or 2 minutes back. So if you use offset time as 10, you will get 172 rows in return, right? So that's the beauty of this procedure, and that's what we are interested in for building this management system, that the user will provide the input. Based on the input, it will fetch all the executed buy sell orders, and once that is done, we'll also get some trade analysis, and once both the things are done, we'll be plotting. We'll do the plots or the dashboard for the user. Okay, now the second procedure is, this procedure is about getting all the required data, historical data using time travel, and this procedure is nothing but doing some data transformation, right? So what we are doing, we are getting all the abnormal trades, that means trades that are not normal, and we are calculating some execution delay by subtracting the trade time and execution time, and based on these delays we are doing some plots. Okay, so now if you come to the project overview, you will see that track order execution delays, right? So this is what we are performing in this procedure, right? And in the previous procedures we have done this fetch historical trade data, so this one is done. Then displaying the trade data, all this will be done in your Streamlit application. And once you have this execution delay also, right, this procedure basically, so you can then go to these things like your compare execution time, detect delayed execution, compare your price versus user price versus market price, identifying the slippage and all. Okay, then your trend analysis and your alerts and your reconciling system, right? All this can be built in Streamlit. So we'll go to the Streamlit and we'll see the details, right? So before going that, as it's not autonomous, right, it's a manual project, so let me just update this too. Okay, so that we have some values to share in the graph. Okay, so once we have the details, we'll just simply go to Streamlit, where we have our data engineer or whatever you say, right? The Snowflake engineer has built already one application that will showcase all the details that's required for the application. Okay, so here in this application, what we are expecting displaying the trading data, showing some graph for historical data. Then we expect some order execution delay details, we expect some price impact analysis, we expect some trading analysis, advanced trading analysis, we expect some reconciling system, some malicious trading activities if happened, we expect some details of that as well. Okay, so here at the very initial beginning, you see this session gets all the credential required for connecting Streamlit to Snowflake. Once that is done, so what we are doing, we are just selecting from the trade orders and the initial table, right, and the current situation, and we're just limiting the top 20 queries. Okay, top 20 order, and we are showing this to the user. Okay, this is your order details. Okay, this is your current status, you can see. And then we wait for how many minutes back historical data the user wants us to show the dashboard for. So let's say the user enters 10 minutes back. Okay, so 10 minutes back, and then it will start fetching the details using these two stored procedure that we have just mentioned, right? One is historical trades, and the second one is get trade details, right? And then it performs all the analysis, and then it gives you all the available trading details of the user for that 10 minutes or 20 minutes, whatever the user will input, it will give all the details, right? So you can see all the execution time, slippage details and all that's available. Then here in the first chart, you can see the trade volume over time. So as the times and everything is random, don't concentrate regard what the plotting is coming in the chart. Just understand the process, how to build one analysis system. So the first plot will be your trade volume over time. The second one is your stock price movement. You can see for all the stocks how price moves with time. The third one is trade type distribution. So this is all the what type of buying or selling, what activities the user mostly do. So for any normal users, so the number of buys needs to be more or less equal to the number of sell orders, right? So that you cannot simply just buy, right, or sell, something like that. That will be unusual activity in any trading account. Now you can also see the stock wise trade volume, right? So that will give you the idea of stock preference per user. So what is the number of quantity of stock traded by that user. So you can see from here that Google stock is traded the most as per the historical data available for past 10 days by user. So it will give them an insight like what are the stocks they are focusing much more, whether it IT stocks or pharma stocks or I don't know, right? Maybe some telecom stocks. Then in advanced trading dashboard, as per the project details details, what we requires, we need some price impact analysis, we need some order execution details, some malicious activity tracking and reconciling system, right? All these plots also we have built. So here also you can see the advanced trading dashboard. We have built the dashboard using the details using this data. So all this data where the trade flag is marked as abnormal. And how we are getting this data? We are getting this data from this stored procedure. So this is what I am trying to see. You can combine task, stream, then time travel, streamlit, stored procedures, and you can build one integrated system where you can showcase your skills as a data engineer, as a Python developer, as a data analyst, and you can build a beautiful application that will have an end-to-end impact in the stakeholder front or user front. So you can see this the first thing that we are showing here is stock price volatility. That means how the stock price fluctuates over time. Second one is how your order flow imbalance happened for this abnormal orders. Okay, so here you can see a huge number of buy trades happened compared to sell trades, then the moving average of these trades, and then you can consider the market price versus trade slippage. So how much slippage happens at what market price, you can also see that. So that's it for this project. I hope that you will not give much more importance towards the plottings and details. You will understand the code, you will understand the workflow, and you will understand how to build end-to-end data engineering systems or small data engineering projects using Snowflake capable systems. So that's it for the first video. In the next video we'll use the same set of features, that means time travel, task, stream and stored procedures, and we'll try to build some more complex project that will have some meaningful impact, and you can also add all these projects to your resume. I will link all of this to the GitHub. You can download from there and you can play along with it, and you can add all of this to your resume to showcase your understanding and your skills to the employer. Thank you very much for watching. I hope you have liked and enjoyed the video so far. We'll meet you soon. Thank you. Bye.